this one, it's going to be this plot, log of this plot, plus log of H2. So this part was just telling you why we do logarithmic scale for both vertical axis and horizontal axis. Okay, now, so I want to know what kind of frequency response this transfer function or this circuit causes. Okay, so the first step that you have to do, and the first thing I'm going to do is focusing on the magnitude plot, and I'm going to do phase plot later, right? Why do we want to do both magnitude and phase? Because we want to know how much our magnitude is going to be amplified or attenuated. And for the phase, we want to know if this circuit, it's going to be leading, it's going to be causing leading output or lagging output, or are we going to be synchronous? Like means like the input and output is going to be in phase. So we have to know both magnitude and phase. So now I'm going to focus on the magnitude. So the first thing, okay, let's decide that first of all, like we have to locate our poles and zeros. So I know that I have one pole at omega equal to 1. So let me just put a cross here. And one pole at omega equal to 100. So let me just put a cross here as well. And I have a 0 at omega equal to 10. So let me actually put a circle here. Okay. So we have located our poles and zeros on the axis here. The next thing we have to do is figure out at frequency equal to 0, means at DC, at omega equal to 0, what's the magnitude, or actually what is our transfer function? What is h of 0? Right? So in this case, it's going to be 20 multiplied by 10 divided by 1 multiplied by 100. So it's going to be actually 2. Okay? Actually make it, let me just, because that's not a very good number. So let me make it 10. Well, let's make it like 100. It's okay if it's 20, but just I wanted to have like a nice number here. So let's make it 100. And then this is going to be 10. Okay. Now, what is 20 log of 10? 20 log of 10. Log of 10 is equal to 1. 20 log of 10 is going to be 20. So we know that at omega equal to 0, our magnitude, it's going to be 20 decibel. Okay. Now, what we have to do is basically locate the poles and zeros, which we have done. Now, what I'm gonna do is basically nothing is gonna happen until we get to the first pole or zero. So everything is gonna stay the same up to here. Okay. Now I'm gonna explain the impact of a pole on the magnitude of the transfer function or any signal. The impact of a pole is, let me actually do also the scaling here. This is 20, this is 0, this is negative 20, and so on. Okay. So, yeah, so the impact of a pole is causing a decay in the magnitude with the slope of negative 20 dB per decade. Okay, so it's gonna be causing this magnitude to decrease with the rate of negative 20 dB per decade. Okay, so up to here, and from this point on, this is supposed to happen. So it means that if we started from 20 dB, the magnitude is gonna stay 20 dB, right? But it's gonna go down with the rate of negative 20 dB per decade. So it means that each of these is called a decade, right? So it means that at this point, if we started at 20 dB, we should get to what value here? To 0, right? Because it was supposed to be 20 dB and it's supposed to go down, so it's supposed to be 0 dB at this point. Okay, if we didn't have any other poles and zeros, this would keep going down forever. But we have a 0 here at omega equal to 10. So 0 would have the opposite impact on the magnitude. So it actually causes the magnitude to increase with the slope of 20 dB per decade. Okay, so from this point on, the impact of 0 it's gonna start, right? From this point, the impact of this pole is started, right? So we were supposed to go here forever, but from this point on, the impact of this pole starts. So what do you think it's gonna happen? These two are gonna fight with each other, and they have exactly the same amount of force, right? This wants to take this down with negative 20 dB per decade. This one wants to take it up with the positive dB per decade. So what's gonna happen? They're gonna cancel out, right? If you just like add these two up, it's gonna be canceled. So if we only had this pole and this 0, then they would cancel the impact of this 0 from this point on would cancel the impact of this pole, and it would go here forever. It would stay at 0 dB forever. Okay? So this is called canceling a pole with a 0, or canceling a 0 with a pole, right? The impact of the pole got canceled by the impact of the 0. Okay? But when we get to 100, we have another pole, right? What's the impact of a pole on the magnitude? You can pause the video and think about it, right? What's the impact? So as mentioned here, it is gonna be decaying the magnitude with the slope of negative 20 dB per decade. So this means that, for example, at omega equal to 1000, you're gonna get to negative 20 dB. And this would keep going forever.